Hello, my name is Ramakrishna, and I am the director of the National Academy of Engineering's Grand Challenges Scholars Program Network. The NAE Grand Challenges for Engineering, identified in 2008 by a committee of the National Academy of Engineering, are 14 critical global challenges for engineering in the 21st century, united by the mission of continuing life on the planet and making the world more sustainable, more healthy, more secure, and more joyful. The Grand Challenges Scholars Program, inspired by the NAE Grand Challenges, reflect the rapidly evolving nature of engineering education. The goal of the program is to prepare engineers who not only have the necessary technical skills, but also the cross-disciplinary knowledge, entrepreneurial spirit, the global multicultural perspective, and a sense of societal mission needed to meet the global grand challenges facing humankind in the 21st century. As of November 2018, 65 institutions across the US and around the world have implemented this innovative educational program, and nearly 100 are getting ready to join the consortium of GCSP schools. We at the National Academy of Engineering are thrilled that Arizona State University has taken the initiative to organize this series of presentations that will highlight each of the 14 NAE Grand Challenges and provide this valuable resource not only to its own students and faculty, but to students and faculty from around the world. On behalf of NAE, I'd like to thank ASU and the Kern Foundation for making the presentation series possible. I'm eagerly looking forward to following how this series impacts and inspires the next generation to create solutions to our society's most daunting problems. Our best wishes for a successful series, and thank you very much.
Hi, everybody. I'm Dr. Remuth. I'm a lecturer at the IRA Fulton Schools of Engineering here at ASU, and I'm going to be your moderator tonight for this event in the Grand Challenge Speaker Series. Today, Dr. Erin Walker is here to speak about the Grand Challenge of Advanced Personalized Learning. After her presentation, you'll have the opportunity to submit questions, and I'm going to ask her some of my own as well. Erin Walker is an associate professor at the University of Pittsburgh with appointments in the School of Computing and Information and the Learning Research and Development Center. She completed her PhD in human-computer interaction from Carnegie Mellon University in 2010. Her research uses interdisciplinary methods to improve the design and implementation of educational technology and to understand when and why it is effective. She works on projects that incorporate social and contextual adaptation into learning environments, including implementing teachable robot for mathematics learning and developing an intelligent tutoring system to help parents and children read together. Walker's work has resulted in many journal articles and peer-reviewed full conference papers, including a Best Paper Award at the Creativity and Cognition and award nominations at the Intelligent Tutoring Systems, Artificial Intelligence in Education, and computer-supported collaborative learning conferences. She was named Phoenix Magazine's 40 Under 40 in 2018. Welcome, Dr. Walker.
So hello, everybody. I'm Erin Walker. I'm at the University of Pittsburgh. And I'm going to talk to you today about the Grand Challenge of Advancing Personalized Learning, and specifically the work we're doing in my lab, looking at social personalized learning technologies. And so in a traditional view of learning, you have an expert standing at the front of the classroom, speaking to a captive audience of students, transferring their knowledge to the students. And so there's this idea that the expert is a sage on the stage, that they have the knowledge, and it's something that they're giving to a mostly passive listening audience. And there are two major critiques of this approach. So one critique of this approach, and that's the one put forward by Brown and Adler and by King, is that it's not sufficiently constructive and interactive. So students should be constructing their own knowledge. They should be developing hypotheses about what's right and what's wrong. They should be interacting with other students. They shouldn't be just sitting passively receiving a lecture. But a second critique of this that I think is also really important is that this doesn't cater to the needs of individual students. And so it's really a one-size-fits-all approach where all of the students in the audience are getting the same kind of instruction. But this has a lot of problems. So for example, 33% of high school students report being bored often in class. So this kind of approach isn't meeting the motivational needs of students. And then also, the thing that will predict the most whether you learn something from this kind of interaction is whether you already had knowledge related to it. So if you have high background knowledge in something, then you're more likely to learn more about that subject. And that may seem like an obvious statement, but what it really means is that people in the class who don't have the required background knowledge or who are struggling with the class aren't going to benefit as much from one-size-fits-all instruction. So it's not tailoring the lesson to what they know, what they don't know, and their misconceptions. And so there's a real opportunity here to put forward this vision of personalized learning. And this is something that people have been thinking about for a while. So in 2010, the government put out a national education technology plan where they said the challenge for our education system is to leverage the learning sciences and modern technology to create engaging, relevant, and personalized experiences for all learners. And so it's imagining a world where you come in with your background knowledge, you come in with your own motivations, you come in with your own preferences for learning, and then you receive personalized learning experiences that are tailored to that background knowledge, to that motivation, and to that preference. And technology has a major role to play in this world. So for one thing, you can use technology to create novel learning experiences. So you can put on a VR headset and tour a historical site and experience it much more deeply than you would if you were simply reading about it. And then if students are interacting with technology in learning environments, you can collect data about how they're interacting with the technology and what works and what doesn't work. So you can start to look at their learning behaviors and see if it means that they're really understanding the concepts more effectively, if they really are more engaged with what they're doing. And then based on that data, you can adapt the instruction in real time to what they're doing. So if you notice somebody is getting distracted, you can give them a more engaging activity. If you notice they're not getting something, you can explain things again or in a different way. So you can close the loop between the data and the learning experience that the student is having in real time. And this creates a truly personalized learning experience. And there's been some early promise to this approach. So this is a screenshot of the Cognitive Tutor Algebra, which is an intelligent tutoring system for high school to help students learn algebra. And basically, students read a problem, and then they do interactive activities. So they fill in a worksheet, they're plotting points on a graph. And as they do this, the system models what they know and what they don't know and gives them targeted feedback at their misconceptions. And the system can also select new problems for them to learn that's tailored to their behaviors as they're using the system. So this is an example of personalized learning that targets a student's domain knowledge and skills. And it's been shown to be dramatically better than traditional instruction in the classroom, and also nearly as good as having students interact with an expert human. But the thing is, there are a lot of levels that you might want to be personalizing to. So a lot of the early successes in this field were at this cognitive level, where you're personalizing the students' problem-solving steps, you're giving them adaptive feedback, adaptive problem selection. But you might also want to be personalizing at the metacognitive level, so helping students choose the right learning strategy, or reflect on what they know and what they don't know and get help when they need help. You might want to personalize at the motivational level, where you adapt instruction to what's going to engage students or not. And also at the meta-motivational level, where you help students motivate themselves as they're going through a learning experience. And so if you're looking for a truly personalized learning environment, you want this personalization to occur at all levels and not just at the cognitive level. And so I want to talk about a project from my lab that personalizes at the metacognitive level And that really tries to close this loop between creating a learning experience, collecting data from that experience, with the potential of using that data to adapt. So in this project, we're trying to help students develop better reading strategies. What they do is they read a text, and then they make a concept map associated with the text. So they extract key concepts, and then they map out the relationships between those key concepts. And we're looking here, how can we design this system so that it better supports their learning in the moment, but also in ways that allows us to collect data to personalize the learning experience later on. And so we've designed several supports within the system. One of them is hyperlink enhanced concepts. So students add concepts to their map, and then as they click on a concept, it takes them to the page where they added that concept. And as they navigate through the book, the concepts relevant to that page are highlighted. So what this does is that if the student is learning a new concept and wants to figure out how to integrate it in with what they already know, they can click on a concept in the concept map, navigate back to where they first read about the second concept, and make that connection between the new concept and the older concept. So it's helping them develop their reading strategy of making comparisons and establishing relationships between concepts in a text. And then we also give students templates to extend where we seed the concept map with existing important concepts in the text and have them build on it. So again, they're learning how to connect existing concepts to new concepts that they're trying to understand. And one of the interesting things about designing this support into the system is that it also provides a nice assessment of whether students are making comparisons between concepts. So because we're logging all their actions within the system, we know when they're navigating back to look at a previous concept, either using the page navigation or using the hyperlink. So we can use that to make inferences about whether they're actually making these comparisons between concepts as they're reading. We evaluated these supports that we introduced in our system, and we indeed found that this hyperlink-based support, where the concepts are hyperlinked to the text, improved student learning over no hyperlink conditions, but it also improved how they exhibited these reading strategies. So for example, they navigated back in the text more frequently when given hyperlink-based support than non-hyperlink-based support. So we had some evidence that this support was effective, that our metrics of whether they were making comparisons between concepts were accurate. And this puts us in a great position to then use those metrics and develop a system that adapts to the student in real time. So we actually built a system right now that looks at whether they're making these comparisons based on their behaviors in the system and prompts them to make more connections between concepts, prompts them with concepts that they might want to connect if they're not making those connections. So we're delivering personalized learning at this metacognitive level. And this project is reflective of a lot of other projects by a lot of other researchers that are trying to deliver personalization at all of these levels. But there's something else here that I want people to consider, and that's the social and contextual element of this. And so part of this taxonomy is actually this notion of caring systems, which are systems that don't just personalize to the individual at these levels, but pay attention to where the individual is, what they're doing, who they're with, to deliver this appropriate kind of personalization. So for example, if a child is reading with their parents, you'd probably deliver a different intervention than if they were reading by themselves. And so this is a notion of social personalization that extends this notion of personalized learning into this contextually sensitive realm. I want to talk about a project right now from my lab that tries to personalize at the motivational level, but by leveraging the social interaction that a student is experiencing. And so in this project, we have a middle school student teach a now robot how to solve a mathematics problem. So the middle school student explains in natural language to the now robot how to solve the problem. And the robot asks the student questions, it gives the student explanations of its own reasoning, and they interact together to basically solve this mathematics problem. And the idea is that this is a really socially engaging interaction. So by interacting with this robot, the students should feel more motivated, they should pay more attention to the domain if they want to explain the problem to the robot. And to enhance the effects of this interaction, we have designed additional social elements into this interaction between the student and the robot. So for example, we have social dialogue. So in this example, Nico is the robot and Juliana is the student. And you can see that Nico's excited. It says, awesome. It says, thank you for explaining, Juliana. You're a great tutor. So it's really using these social statements to try to motivate Juliana as she's explaining the math problem. And it also uses acoustic prosodic entrainment, which is adapting its tone of voice to the student. So as the student's pitch goes up, Nico's pitch goes up. And as the student's pitch goes down, Nico's pitch goes down. And the reason we do this is when humans are talking, they adapt their tones of voice to their conversation partners to show engagement. So if a robot did this, it might also show engagement. And indeed, when we evaluated this, we found that this social personalization was effective at increasing learning. So the fully social version of this system led students to learn more than a non-social version of this system. We also found that there was a trend where the effects were different by gender. And we've found this across several of our studies, where it's apparent that based on students' individual differences, they want the robot to be more social or less social. And another real opportunity for personalization here is to look at a student's individual characteristics and tailor the level of socialness of the interaction to that. So that was an example of how we're doing social personalization at the motivational level. Another thing we're doing in our lab is trying to do personalization that is fully socially and contextually sensitive. And so we have this project where we're examining how we support individual students in transferring their skills from one context to another, and how the level of personalization we might want to deliver is different based on the context. So in this project, students are interacting in this system we call Model Book, which is a discussion forum where they post their work in class and then comment on other students' work. And these are middle school students who are interacting with people from the same class as them. But then we ask them to go to Khan Academy and answer people's questions on Khan Academy on a similar topic surrounding videos they've watched. So we get two contexts for a similar kind of interaction. One when they're interacting digitally, but with students from their class, and another where they're interacting in a public forum. And we're curious about whether students interact the same way in these different contexts and how we can provide personalized support in each context. So this is ongoing work. So we're still developing this system in our personalized support. But we have found that context is a much bigger predictor of how students are interacting than their individual differences. So they give each other more help on Khan Academy and better help on Khan Academy than they do on Model Book. And so we're developing a model of what leads students to participate effectively in these contexts. And we're going to use that model to deliver them support that gets them to participate more effectively, give better help depending on what context they're in. And so this is a whole framework for where you might want to personalize. I'm going to close with just two open questions that I think the field needs to answer to move forward. And so one of them is how we can integrate across these multiple levels. So people are developing a good sense of how to deliver cognitive support, how to deliver metacognitive support, motivational support. But how do we decide at any given moment whether a student needs help with their motivation or help with their domain knowledge? And how can we use what they're learning, how they're learning it, to give us insight into assessment at these different levels? So can we look at what they're doing as they're trying to solve the problem and make inferences about their motivation? And I think this is going to actually require a huge effort to develop different supports at these different levels and integrate them together. And then the second one is the question of adoption. Even if we can design this idealized, personalized learning environment, how does it fit into what students and teachers are doing in the classroom right now? How do we design it so that teachers want to use it, want to incorporate it into their classroom activities so that it's intuitive to students? And then looking towards the future, how does it fit into the classrooms of the future where maybe there's a higher presence of technology, a lot of data being collected, and students and teachers need more agency in making decisions about their own learning, using technologies that should empower them versus technologies that make prescriptive recommendations for what they're doing. So looking both at the current landscape and a future version of education, we need to be thinking about how to design these personalized learning environments. So thank you very much. I talked a little bit about my lab's vision for social personalized learning, and I'd love to take questions.
I hope all you guys had learned some great new things about the Grand Challenge of social personalized learning, and this has inspired you to learn more and to look into ways that you can help solving this. For the rest of the talk, we're going to be taking your questions. If you are here in the studio, you can text your questions to the number that's provided in the program. If you're joining us over the live stream, you can put it into the YouTube chat, and they'll be sent to us, and they'll be asking the questions of Dr. Walker. So we can have a seat. All right. So we're going to start off with some questions that I have for you. And my first one is, one of the systems that we use at ASU that some of our students might have experienced is the Aleks system, which is an adaptive algebra learning system. I was wondering how that sort of fits into the taxonomy of the things that you showed us today.
Right, and so my understanding of Aleks is that it delivers a lot of really great personalization at the cognitive level. So selecting what problems students should learn next, sort of identifying what students know and what students don't know. And I think that's a really important piece of this whole puzzle, but moving forward to move towards true personalized learning, you'd want a system that delivers personalization across all of the levels that I talked about.
Yeah, and I think that's reflected in some of what I've heard from students too, is that it's very kind of grindy. Like you spend a lot of time just tackling a problem, and then there's no like encouragement or anything. It's just another one that comes next, and that might be what's missing in that experience for them.
Yeah. Although then designing that kind of encouragement is it's very challenging, right? So you kind of understand that you need to take different pieces of this at a time, and then thinking about, okay, now what do we know from how students are using the system? Which students are getting demotivated? What steps do we take there? It's sort of a more complicated problem than
you can't just
a quick fix.
You can't just say good job at the end of every problem
exactly.
and it'd be okay.
Yeah.
Right. Yeah. Awesome. Some of our class sizes are really large, over 200 students. How are things like this scalable, and how can we try to integrate that into our large classes?
Right. So one of the big advantages of these kinds of technologies are they're highly scalable and sort of in ways that you might not expect. So in terms of large class sizes, students can get more individual attention than they might otherwise get by going through sort of interactive problem solving and getting feedback, like in the way that Aleks just delivers interactive feedback. But one thing that these systems can also do is assess students' knowledge and group them with each other based on what they know. So then you have these groups that are made up of different knowledge levels and different skill sets and working on projects. You can, in the moment, figure out that one student isn't understanding something and connect them opportunistically with somebody else digitally as they're doing their homework, or connect them with other resources online. And so I think the technology scales nicely, and students end up getting a lot more support than they would just sitting in a lecture hall or even working on their own.
That sounds really exciting. Are there tools that are available for that to happen now, or is that something that's currently being explored?
So in terms of that sort of intelligent facilitation of collaborative learning, my understanding is that it's currently being explored. So there are tools to help you make groups in the classroom, but not that can really, in the moment, assess student skill sets and then assign them to groups. And part of the challenge there is that it's this integration between multiple levels, right? And so you need to both have some mechanism of assessing what they know, and then some knowledge of how to group them collaboratively and what might be effective. So it's also sort of a big technological challenge to be able to do that.
Are any of these technologies being utilized in like the online learning space besides the classroom itself? Is there any online research being done?
There's a lot of research being done on massive open online courses and other online courses. And that's one of the major test beds for this sort of research because you have access to so much data. And so you can start using data to make predictions about what's going to be effective and what's not going to be effective rather than using theory alone. And I think this combination of theory and data is where you really get great strides.
Awesome. Besides the couple of questions that you ended with in your talk, what do you see as some of the biggest challenges facing our education system as a whole?
Yeah, so I think that, I mean, I do really think that adoption is a huge challenge in general. And I think in our education system, at least in the United States currently, teachers have exposure to a lot of different kinds of technologies and pedagogies, and sometimes pressure to adopt one or the other. But then when they try to take it into their classrooms, they don't have the training or the time to be able to use them effectively, and then everybody gets disillusioned with them. And so there's a lot of great stuff out there, but it's not being designed in a way that facilitates adoption. And I think once we get over that barrier, we'll be making a lot of strides. And it's the other big thing is just the challenge that personalized learning is trying to address. The individual students' needs aren't being adequately addressed all of the time by the kinds of instructional techniques that we had. And so I think by developing these kinds of technologies, but with an eye towards real scenarios and adoption, we can start making progress.
Have you seen any, there's clearly like resistance from instructors on adopting these things because change is extra work and they've always done it this way sort of thing. But students on the other side have developed strategies for survival in educational systems too, all through K-12 and stuff like that. Have you seen any evidence of a resistance on that side?
Yeah, absolutely. So I've done a lot of design work with students across all of these projects, and there's a lot in the design of these technologies that can make students' lives more difficult and not less difficult. Like if they have to do a number of different exercises that they wouldn't have had to do before, and they don't see the value in it. Or even if something is challenging to log into, if there's a usability issue, it starts to feel pointless. If they end up going through several different problems in a sequence once they've already mastered it, the technology doesn't function as it's designed to, then they become disillusioned with it quickly. And so I think there are really valid reasons for resistance from all stakeholders, because if what they're using is not well designed, it actually is more work and less beneficial than maybe what they were always doing.
Yeah. So I think that might sort of lead into this other question. Is so in robotics and some of these humanoid robots and stuff like that, there's the Uncanny Valley. If it's too real or if it's not real enough, it's not a believable character. Is there something like that in the social learning systems that you're working with?
Yeah, so I think that that's something that we think a lot about in terms of not making them too human-like. What we really want to achieve, we want it to be clear that it's a robot, and to a certain extent it's a tool, but it has these social behaviors, and so it's engaging to interact with. It can facilitate learning in that way, but as a robot, not I think there is something that certain people get uncomfortable with if the behavior is too human-like, and it also seems inauthentic in some ways.
Yeah.
And so I think it's about finding that right model for what these kinds of pedagogical agents should be doing and the role they should be taking, which is different than maybe the roles that we have right now certainly between humans, but maybe also for agents.
Yeah. What other new technologies and developments are you most excited about that are coming down the line?
Yeah. So one thing that I'm really excited about is the developments that are happening with teacher support tools. And so there are a lot of developments where teachers are getting fed this information about how students are learning in the class, how they're using the technologies. Sometimes they're given the information in real time or as an after-class reflection, and then they can use that to make decisions about their own teaching and what's best for the students. And so I think that's really exciting because it's really empowering for teachers. It's giving them data that they need about how to sort of direct their classroom. Another thing that I'm really excited about is there are citizen science projects where students participate in scientifically meaningful activities as part of their learning experience. They might be going out and collecting data on water quality, that kind of thing. So I think that use for technology is really cool because, again, it empowers students to work on a meaningful problem that has a real-world impact, but they're also learning to do it.
Awesome. I'm going to start in on the audience questions. This first one mentions that they've been repeatedly told that handwriting notes is better than typing notes. How does this affect the role of personalized technology for learning new concepts?
Yeah, so I think this is another vision of the future that you're going to see. The reason, from what I understand, that research shows that handwriting notes is better is because of the kinds of memories you create through the embodied act of handwriting, the kind of care you have to take in it rather than typing. And there's a lot of stuff with representation, right? So if you're writing out formulas or trying to draw a diagram, there are some ways where it's easier to do it freehand than it is by typing on a computer. And I think what we're going to see in technology going forward is away from sort of this mediated interaction where you're at a computer and typing in, and more in this ubiquitous vision of technology where maybe you're building a model and that model is digitally instrumented. Or you're drawing on a whiteboard, right, and the board is smart and it can recognize your handwriting and maybe transfer those notes into a digital format. So I think this is sort of the growing pains of how we're interacting with the technology that in 20 years, it's all going to feel very, very, very natural.
Right. Yeah, because even the like tablets and handwriting recognition is maybe 10, 15 years old, much less adapted perfectly into the systems that we have now.
Yeah, exactly.
Right. Awesome. In your research, how comfortable were the kids and people in general in interacting with your social robots?
With the robots. We get a range of interactions, but the kids do tend to like it for the most part. And the interesting thing is we've run one study where the same kids used it over multiple sessions, and kids got more comfortable with it over the multiple sessions. So initially, they're not quite sure how to talk to the robot so that the robot is going to understand them and produce sensible responses. And then as they interact with the robot more, they get in they start to become comfortable with how to talk to the robot, what the robot's going to say back. And so we do get a range, and it does seem to be related to how comfortable students are with technology in general. And I don't think a social robot is for everybody. And some students have made it clear that the social robot is not for them. But for the most part, the students that we've worked with seem to find it very engaging.
They kind of had to learn to use the tool a little bit as they were interacting with it?
Yeah, and I think they indicated us in interviews that at first they weren't too sure what to expect. And then once they started to know what to expect, then they started to enjoy the interaction more.
Awesome. How did you test the improvements in the kids' ability to learn? Was it through the data of them clicking hyperlinks, or was it also testing them in the information that they learned?
In my lab, we tend to do pre-test and post-test. So you give them a test before your intervention, and then they go through the intervention, and you give them a test after the intervention and look at their gains. And we correlate that with the behavior-based metrics, but we tend to use that as a ground truth for how much they learn during the
Cool. Are you aware of the utilization of any of these technologies for students with cognitive disabilities?
So I know that there is research on that. That's not something that I'm personally very familiar with in terms of what's out there, but that is an active area of research.
I think it was something we were talking about outside is new things are sometimes said that on average it's better, but it's those sort of outliers that I think you're trying to hit too, is the customization towards
Yeah, and there's a big movement in the field now to consider everybody as individuals and these outliers as valid data points versus just as something that's moving the average one way or another. So even the methods that we use to analyze improvements are very mean and standard deviation based. You look at the average performance, you look at there's an improvement, and people are just now starting to move away from that towards models that really look at an individual's trajectory over time so that we can really personalize to each individual versus just to the average person.
I think there's trends like that in like personalized medicine and things like that, rather than just saying, you know, that the people that it doesn't work for, that's a data point too, and there might be something that works better.
Yeah, and I just saw a really great keynote on accessibility. I'm blanking on who gave it, unfortunately, but she made the exact same point too, that you really actually want to be targeting these outliers and then moving in towards sort of the average versus working the other way.
Did in your research, as you were sort of looking at these outcomes too, did you see you had general gains, but for the students that were in like the lower quartile or the higher quartiles, did you see differences in those?
In terms of how they...
In like your initial, like for the pretest, if they started out low, did they gain more? Everybody sort of gained the same?
No, we do tend to have a lot of variation in how much people are gaining, and that's where our strategy right now, and I want to move more towards individual level analysis, but we do a lot of correlation between the behavior-based metrics and the pre and post metrics. So that's where, like with the concept mapping example, if we're targeting these reading strategies, if they use these reading strategies more frequently, did they learn more? And we do see those correlations. For the social robot example, if they're expressing more rapport to the robot, like saying good job, that kind of thing, do we learn more? We have seen that effect in one of our studies, not across all of our studies. And so that's been our strategy with that so far in terms of looking at who's learning and who's not learning. We've been looking at it within the context of both, are they responding to the intervention, and also what are their individual characteristics? But I think that we could be doing more, and I would like to be doing more going forward.
Awesome. What sparked your interest in personalized learning in the first place?
There are a lot of versions of that story, I think, but I think that I was really unsatisfied in high school and in college with the lecture model of instruction and teaching, which is mostly what I had been exposed to. And then I discovered human-computer interaction, which is a field where you look at how to design technologies for human use. And a sub-area of that field is educational technologies and the education application. And so when I started getting more interested in human-computer interaction, education was a really natural application for me because of my own personal experience.
Awesome. As personalized learning becomes more advanced, do you think human instructors will be completely replaced? Will be out of a job?
So that's not my vision of the future. That does seem to be a pretty dystopian vision of the future. I think that when human instructors are out of a job, maybe we're all out of a job in that vision of the future. So I'm really motivated to design technologies that enhance people's capabilities, enhance teachers' capabilities to facilitate what's happening in their classroom, and empower people to make decisions about their own learning versus something that's going to replace a human in the equation. Even our social robot, part of our idea with that is that the students are going to teach the robot, and then they'll go teach another student. And they've gotten practice by teaching the robot. So we're looking at that transfer right now. The robot is practice for collaborating with one of their classmates.
Do you think the use of robotics in learning may cause children and young adults to exhibit antisocial behaviors?
So again, that's not the vision that I want to be putting forward. So I'm hoping that these technologies help to bring people together versus that it's a one student, one computer scenario, and they're just working individually at home, trying to solve problems, or working with their personal robot, interacting with it. my hope is that they move between those kinds of interactions, and then the technology facilitates interactions with other people.
Yeah, I know that I've heard a few times that parents make their kids say like please and thank you to Alexa and things like that to try and make sure that happens. Practice that good behavior. To you, what does the future of personalized learning look like?
Yeah, so I think that it is this kind of scenario where you're really paying attention to the social context and to how to empower the people involved. And it's this interplay between different contexts. So you, as individual, could have a personalized agent that follows them through all their learning experiences in the classroom, at home, if they're working on homework with a friend, and maybe suggests resources or gives them tools to look at or suggests somebody that they might want to talk to. And it's facilitating their interactions and sort of understanding their learning trajectory as they move from context to context. So my vision of this future is that whatever personalized agents we have are embedded in the context and helping the student interact within that context versus something that is, a single tutor for a student, and it separates the student from the other learning opportunities.
Awesome. Every time I hear about personal assistants, I always go back to like Clippy and that guy. Why do you think why did that fail so profoundly?
Well, it was kind of annoying, right?
Right.
And it wasn't empower. Like, it didn't give the user a lot of agency, if I remember correctly. It was sort of, we would pop up and make all of these suggestions that the user didn't feel like they needed. Mm-hmm. And that's another, reason that user-centered design is so important. What does the user perceive they need? And then in the case of learning environments, what do we know from the literature that's going to contribute to their learning? And how can we find that intersection so we design something that's beneficial for learning, but also something that people want to use?
Mm-hmm. I think Clippy was probably designed by engineers and not tested on any normal people. So they didn't really know what to expect. And I think the human-centric approach is probably what is missing there.
Yeah.
Will there be any AI-based learning websites for higher levels of math, like calculus, do you think?
I think there already are. And it's just getting more and more common. And so that is a pretty well understood problem right now. How do you design an interactive problem-solving experience where you can assess what somebody knows and gives them feedback? And so people are implementing that. One thing that is on the forefront is then what do you do with that data? So especially if you're delivering it on a web platform, then people can, every time somebody uses it, they're generating a new data point for you, and you can start making predictions about how they're going to do on the platform and use that to tailor your feedback. So for example, Assessments is a platform that does a really great job of this, where it's used as a homework tool, it's used in classrooms, and it collects a lot of data, and then is always refining the kinds of problems it delivers based on what's working and what's not working, the kinds of interactive activities it delivers. And so, one major advantage of that approach going forward is just that you can make decisions more quickly about what's working.
Great. You mentioned in your talk how you adapted the social level of the robot based on whether individuals were more social or less social. How did you measure how social a student is, and is there a way to measure that?
So that's future work. That's not something we've currently done in terms of adapting the social personality of the robot based on what students want. The best evidence we have so far in terms of individual characteristics is that comfort with technology makes a huge difference in how social students want the robot to be. But I think that we can also make inferences based on whether they're responding to the robot socially, if they enjoy it when the robot responds socially back, or if they would like the robot to be a little bit less enthusiastic, less social in that way. And so that's where my lab is going, now in terms of looking at those sort of moment-to-moment interactions and what that might mean about how the students perceive.
So if the student's experience with technology is a major indicator of how they're going to interact with it, are you worried about like the digital divide and making that worse or making it better in these interactions?
I think that's just a huge advantage of this personalized approach. So I don't know that there's anything that would suggest to me that enjoying using a social robot would be better than enjoying using a non-social robot. So if some students are more engaged with the social version and some students are more engaged with the non-social version, it seems natural to me to present students with the version that they would be most motivated by. And one thing that would be really empowering in this scenario is you could also just ask students what they'd prefer and give them the version that they prefer. And that might be the most motivating. Like there's a lot of research that suggests that choice in those ways is very motivating.
Great.
That's a good thing.
Awesome. So we're getting near the end here, and I'd like to return to a call to action, right? So I'm sure Erin has inspired you to take action. So how can students or others get involved with the kind of work that you're doing? What are some first steps that they could do to address these challenges?
So, I mean, I think that, you know, everybody in here has experiences being students. So you kind of know, you already know the population you're designing for, at least at the college level. You know what works for you and what doesn't work for you. And so really working on applied projects, trying to either improve environments you understand or reach out to audiences and users that are more distant from you and talk to them about their needs, look at how they're learning. If you're interested in working on these kinds of projects, forming interdisciplinary teams where you maybe, if you're a computer scientist, partner with somebody majoring in education and working on smaller hands-on projects to try to get a sense of what works and what doesn't. I think those are good ways to take immediate steps towards, you know, advancing this field as a whole.
Great, awesome. That's all the time we have tonight. Thank you all for joining us, and please check our website for more information on future events with the NAE Grand Challenges Speaker Series. Please join me in thanking Dr. Walker again for an inspiring talk this evening.